Now the topic is double hashing. We have already seen linear probing and quadratic probing. Those were the methods for resolving collision. So this is also a method for resolving collision. The idea here is we will have two hash function. One is the basic hash function. Then if there is a collision, then the other hash function will help us to remove collision. So for explanation, I have taken an example here. See, this is the first hash function, x mod 10. So that is a regular hash function that we have used in various examples. So h1 is x mod 10 because the size of the hash table is 10. Then this is the second hash function. That r is a primary number that is smaller than the size of the hash table. So the size of the hash table is 10, and less than 10, what is the nearest prime number? That is 7. So r should be 7. I will modify it. So I have modified it to 7. Actually, second hash function is having two desired properties. One is it should never give a result 0. It should not give index 0, first one. And the second thing is it should try to probe all the locations. Means whenever there is a collision, it should not give the indices in the same pattern. It should give different indices such that all the locations are utilized. So for that, the suggestion is this form of hash function with a prime number. So this is the suggested hash function, so we use this one. Or else you can design any other hash function you like. But two things you have to take care. The result of that hash function should not be 0. And the second thing is it should try to cover all the indices. The next thing, we will use regular hash function. If there is a collision, then we will try to use this modified hash function. So let me explain this modified hash function. This is h1, this one, same, plus I into result of second hash function. And this entire result is mod by the size of the hash table. Then this value should be multiplied by I, where I takes the value 0, 1, 2 onwards. So it is similar to linear probing and quadratic probing. So when first time when you are using, I value will be 0. So this is of no use. So we can say that directly we'll use this hash function for first time. Second time onwards, I value will be 1, then this is considerable, then we can use this modified hash function. So for demonstrating double hashing, I already have a key space and the hash table ready. Let us map these keys on the hash table using this double hashing. So let us start. First key is 5. 5 mod 10 is 5 only. So this is mapped on a location 5. So 5 is stored here. Then 25. 25 mod 10 is 5. So this is again mapped on the same location. So this is a collision. Then I should use this modified hash function. Modified hash function for 25 is this result we got it as 5. So 5 plus I should be 1 now. Earlier I was 0. That's why we took directly 5 and found that there is a collision. Now I should be 1 into h2 of x. So I should write on 25 here. So what is the result of 25? I will calculate it. 7 minus 25 mod 7. So this is 7 minus, this is 4. So this is 3. So it should be 3 mod 10. This will be 5 plus 3, that is 8. So 25 should be stored at index 8. So 25 is stored here. Now next 15. See, the keys I have taken all are ending with 5, so they will collide with this index, right? So all are colliding only, so we can see its extreme cases also. So let us map 15. 15 mod 10 is the same index. Collision. Now let us use this modified hash function for 15. The result of this function was 5, so that is a collision. 5 plus. Now 1 into, we have to get the result of this function, that is h2 of x. X is 15, so I will evaluate this one. 7 minus 15 mod 7. 7 minus, see, 7 will divide 15 for 2 times, 14, remainder is 1. So this is 7 minus 1, this is 6. So this is 6 mod 10. So 5 plus, 5 is for this one, plus as it is, I is 1, then h2 of x is 6 that I have evaluated here. So this is 11 mod 10. So the answer is 1. So this 50